That's it now. This is the question, right?
Yes, sir.
Okay. Nothing else, right? I mean, इसके आगे पीछे कुछ नहीं था.
No, sir.
So 3D5 is kind of odd, but 3D5 will be the atomic number of elements whose outermost electron are represented by. 3D5 can be either, it can be copper and manganese also. 3D3 will be CV, vanadium. From where did you get this question? So they are asking atomic numbers. So atomic number will be 24 and 25. This will be 23. Okay. Achha, you want me to explain how to do it?
Yes, sir.
You got this. Achha, fine. So 3D5, that means the inner shell electrons are filled, right? Before 3D5, everything is filled. So what will be before 3D5 to be the second shell and the first shell. So 1s2, 2s2, 2p6. So all of these are filled. After 2p6, we have 3s2. Then we have what? 3s2, 3p6. Then we have 4s2, 3d5, right?
Yes, sir.
You can have something like this. Okay, now you see 4s2 and 3d5. I mean, 3d5 can be there in two different ways. This is the inner shell. These are inner shell electrons, and this is the fourth shell, that is the outermost. Then you can have either 4s1, 3d5, which is the case of not copper, Sakti V Kraman. This is chromium. For chromium, you can have 4s1, 3d5. You can also have 4s2, 3d5. This will be for Mn, that is manganese.
So then forest shell will be the outermost shell, right?
It is just saying that the outermost electrons. So both of these you will be considering as the outermost, because when you are going to write the outermost electronic configuration of D, then you will write it something like this, right? NS2, and then we write N minus 1 D1 to 5, sorry, 1 to 10. Also, where is the last electron going? It is going in the 3D, right? Yes or no? Correct, Harsha?
So can you repeat?
I'm saying that the last electron, if I have to fill, let us suppose 25 electrons, then till 20 it is here. Then the last 5 electrons are going in the 3D5, right? Yes or no?
Yes, sir.
So that will be the outermost. Got it now?
Okay. Yes, sir.
Okay. So in the last lecture, we saw thermodynamics, and we were looking at the what were we looking at? Tell me, guys, if anyone remembers, what was the last topic?
Pressure volume work.
It was pressure volume work, right? Okay. So in pressure volume work, we ended up with a formula. What was that formula? For pressure volume work, what was the formula? Tell me. Anyone remembers?
P work is equal to P external change of volume.
Work done is equal to minus P external into delta V. Correct? This was the formula that we ended up with. Correct? Yes, and all of you, please tell me.
Yes, sir.
Okay. We will do a very simple question. We will do a very simple question. Just the thing is that you don't have to hurry here. Okay? You have to understand each and everything very slowly. जल्दी करने की यहाँ पे जरूरत कुछ है नहीं. Write the question. A gas absorbs 120 joule of heat. A gas absorbs 120 joule of heat, है ना? अब देखिए बिल्कुल इसको ना सोच के चलिए, ठीक है? All of you, please try to think what is happening. We have a gas like this, okay? And in this gas, what is happening? in this gas, we are heating. Okay. Now, when we heat, two things can happen. If this is closed system, completely closed, that means this piston cannot. It is rigid system, I would say. No? The boundary is rigid. It is not flexible. Then what will happen? Tell me. If we are heating something, then obviously the temperature will increase. Correct? Yes or no?
Yes, sir.
Achha. But if we have flexible, it is not tightened, it is flexible. That means it can go up and down. And then we heat, then what is going to happen? If we heat this particular thing, then what's going to happen? This will rise. Piston will rise. Correct, guys? Yes or no? Please tell me.
Yes, sir.
So we will say the gas is expanding. That means the volume will increase. So when you heat a system, then there are two things that can happen. Either the temperature will increase or the volume will increase, or sometimes what happens, both increases. The temperature also increases and the volume also increases. Then in that sense, what is happening? Tabito, all of you guys must have seen that many of the computers, many of the mobile phones, many of the motors, many things, it get heated. All of you have seen that? Yes or no? Please tell me.
Yes, sir. Yes, sir.
Very simply, I'm explaining this. Please try to understand. Let us suppose I made a machine in which if I give energy, I am giving energy, and this energy should be used. Please listen to this very carefully. Should be used to lift this piston up. That was my machine's work. Simply, my machine's work was to lift the piston up. But what happens? It is not lifting it efficiently. That is why there is some increase in temperature and some of my energy. We say it is wasted, but scientifically we cannot create energy. We cannot destroy energy. So scientifically it is getting wasted in the sense. But when we say wasted, that means it is not getting used in the way which we want. We wanted all the energy to get used as for the lifting of piston, but some of the energy is being used for the increase of temperature. Okay. So I'm only half at the question. I'm just giving you ideas that how to read the questions and what things should pop up in your head when you hear something. And a gas absorbs 120 joule of heat, then what can happen? Think on those direction. I just want you to do that. Okay. Now, let us see what the question is saying now, whether it is temperature is increasing or the volume is increasing. 120 joule of heat, and let us suppose it expands. And it expands against external pressure of 1.10 atm from a volume of 500 ml to 2 liters. 500 ml to 2 liters. What is the change in internal energy? In internal energy. Okay. Now, what is internal energy? If you remember, internal energy is just the sum of what? Just the sum of the heat involved in a process and the work done in a process, right? So delta U, it is nothing. It is equal to some heat, whatever heat is involved. Either it is given out by the system or it is taken in by the system, or work done by the system or taken. And we will take the positive, negative according to the situation. But it is heat involved plus the work done. Now, what are the things happening here? Please see very carefully. Don't write anything. A gas absorbs 120 joule of heat. So our system is a gas and it absorbs 120 joule of heat. Then what does it mean? Q, it is absorbed. So Q will be positive or negative? First of all, tell me that. Q will be
Positive.
Positive. Very good. So Q is positive and it will be equal to how much? 120 joule. Correct, guys? Yes or no? Please tell me.
Yes, sir.
Okay, positive 120 joule. Now let us see what is work here. Now, what is happening? The system is lifting the system is expanding. So it will be expanding only if it lifts the piston up. And the piston is also having work done against some pressure. See here, guys. See very clearly. There was an external pressure of 1.10 atm. And still what is happening? The gas is lifting the piston up. So gas is doing the work. Correct, guys? Yes or no? Please tell me.
Yes, sir.
Gas Okay, so the work will be what? Work will be obviously negative, and what will be the work? Work will be equal to, as we have seen, minus P external into change in volume. P external into change in volume. Now, what is P external? P external is equal to, I will take the minus here, 1.10 multiplied by the change in volume. What was the final volume? 2 liters. So that means 2 minus, how much here? 0.5, half liter, right? Now, this will be equal to how much? Minus 1.10 multiplied by 2 into 2 minus 0.5 will be equal to how much? 1.5? Yeah, 1.5. Now what they are asking, this is the, yeah, fine, this is the work done. And as you can see, the work done that we have got will be negative here, right? What will be the value? 1.10 into 1.5, 1.10 into 1.10. And what is half of 1.1? 1.1 is 65. So it will be 1.75. If you multiply this, can you please tell me, are you getting the same thing?
1.650.
Yeah, 1.650. Right? 1.6501. Now, what will be the unit? The unit will be liter ATM. And the external is in what? ATM, and the volume it is in liters. So liter ATM. Now, you have to know one relationship that will be very useful. It is an approximation. 1 liter ATM is approximately equal to 100 joules. And if you, I mean, it is just a play of units. Okay. Maybe you must have done this in physics. Have you seen liter ATM in joules in physics till now? First chapter, unit dimension and measurement, ever? If not,
No,
then
sir.
please, हाँ नहीं, तो देखना मतलब होगा कहीं ना कहीं, ठीक है ना? You try to go through unit dimension and measurement, you will see this conversion, liter ATM to joules. 1 liter ATM, it is equal to 100 joules. है ना? Let us first get used to this particular 1 liter ATM, it is equal to 100 joules, and then I will show you how it is equal to 100 joules also. Okay. So in this case, I can write, please see, minus 1.65, and liter ATM, instead of liter ATM, I can write 100 joules. So multiplied by 100 joules. Now this will be equal to minus 165 joules. Is that clear? Yes or no? Please tell me.
Yes, sir.
Okay. Now what is delta change in internal energy? They ask. So I will write change in internal energy. Delta U, it is equal to Q plus W. Q, it is equal to 120 joule because it is absorbed, plus what is the W? Minus 165. And now whatever answer will be there in joules, this will be equal to how much? Minus 45 joules. Correct? All of you got this? Yes or no? Please tell me. Please write this down. If you have not written, let me know once you're done. Have you guys done any integration or differentiation till now? Integration with the differentiation for you.
Physics.
Integration. You have done few things, all of you.
Yeah. Yes, sir.
You know about upper limit, lower limit, right?
Yes, sir.
Okay, fine. If everyone is done, I will move on. All of you done, yes or no? Mariam, you understood? Siddiqa, you understood this? Abdul Hamid?
Yes, sir.
Okay,
Yes,
fine.
sir.
Please repeat these questions once you are, I mean, once you are over with the class. Now, when the class gets over, please repeat these things. Okay. So now, let us see the work done. Now, the reversible work done. If you remember, the last time we started, now, then we said that the pressure volume work that we were talking about, it was irreversible, and that is why we took a large change in the volume, and instantly there was a large change. What happens if we do very small changes? Then in that case, we will be talking about the reversible work. Please write here reversible work. Now, the things in the reversible work will be a bit different. For example, the displacement of piston last time we took it as L. क्या लिया था हम लोगों ने? देखिए जरा, we took the displacement of piston पिस्टन लिख दिया पिस्टन. This was taken as L, right?
L.
Length L. ठीक है. अच्छा, जब हम लोग यहाँ पे छोटा सा चेंज करेंगे तो बताइए क्या हो जाएगा. This will be equal to small change in the displacement of piston. What should I call it? Try to remember a bit of physics. Small displacement. Small चीजों क्या बोलते हैं? भूल गया सब. Oh my God. अब्दुल हमीद, अब्दुल्ला. अरे डिस्टेंस नहीं बोलते हैं, कैसे डिनोट करते हैं?
dx.
हाँ, very good. So this will be DL. Is this clear? Yes or no? Please tell me, guys, all of you.
Yes, sir.
Yes, sir.
And if there is a small displacement in the piston, then obviously the volume of the gas will change by dV. Correct? है ना? The volume
Yes,
change
sir.
will be. अरे सारे भूल गया लगता है. देख लीजिए, थोड़ा सा दोबारा देख लीजिएगा. बिल्कुल ठीक है ना. ये हमारे पास एक सिलेंडर था, है ना. We had this cylinder and then there was a piston like this. In this piston we did some work, है ना. We did some work, so this piston moved. This piston moved, so we had dl, and the volume is given by the area of the piston, the circular area, है ना, जो भी है, multiplied by the displacement of the piston. So the volume will be equal to how much? Volume will be equal to the area will remain same of the piston, है ना. Whether we are doing the reversible work or irreversible work, in both the cases, if we are using the same cylinder, the area will be same, but the displacement, because we are having small change, it will be multiplied by dl. So dV is equal to what? The change in volume is equal to A into dl. And as we have seen previously, P is equal to force upon area. That is why force will be equal to pressure into area. And we already know that what is area equal to. So we can write dW, that means small work done will be equal to force into displacement, that is dl. Displacement, that is dl. Now this will be equal to what is force? Pressure into area into dl. Pressure into area into dl. The force is equal to pressure into area. Work is equal to force into displacement. So dW, that means small work done, will be equal to pressure into area into dl. And area into dl is nothing but dV, small change in the volume. And this will be dW. And in order to keep the signs appropriate, we will put up a negative sign. P external minus of P external dV, it is equal to dW. Now we are going to integrate on both sides. This is very easy. इसके बाद और थोड़ा सा है, ये तो बहुत आसान है, आसानी से देखते रहिए. Integrate on both sides. Then we will be getting dW is equal to integration of minus of P external into dV into dV. Now obviously the integration and differentiation, this will become work, and we are talking about reversible work, so I will write W reversible is equal to minus P external is the constant, so it will come out, and we will have integration of dV. Integration of dV from where to where? From V initial to V final. V initial to V final. हाँ, ध्यान से देखते रहिए, बहुत आसान है. This will be equal to minus P external. Integration differentiation cancels each other out. I hope you know this. And then this will be just V remaining. The lower bound will be I and the upper bound will be Vf. Now Vf minus Vi we are going to write. So minus of P external into V final minus V initial. This will be the reversible work. This will be the reversible work. I can easily write this. V final minus V initial is delta V. So there is not big change when you see it like this. P external into delta V. So please write this down. छोटी सी चीज है, लेकिन इसको please लिख लीजिए. There is not much difference between the reversible work and irreversible work if we look from the lens of external pressure. Now we are going to represent the same thing using internal pressure. Okay, using internal pressure. That is more important. उसको ध्यान से देखिएगा. And I will also tell you the reason why we are looking at the internal pressure, है ना, and not at the why do we need a formula or a derivation of work done using internal pressure. Please write this down. Let me know once you're done. Anyone still writing? Is anyone still writing? No one is writing. Okay. Now please see. थोड़ा आप लोग जवाब दीजिएगा, ठीक है ना? वो तो बोलिए. You have to speak ना.
answer.
Now, let us suppose we have some container like this. Okay, this is the piston, and we have some gas here. Okay. Now, whatever we do inside the system, we have to talk about all the things which are inside the system, right? Like if I want to talk about the state variable or state function or path function, whatever variables we are going to talk about, we are going to talk about the system. What is the pressure of the system? What is the volume of the system? What is the temperature of the system? So if we are only talking about the things which are inside the system, why do we have a formula in which we have P external? That is not very useful. It will be very useful if we have in the formula the P internal. If we have in the formula what? We have in the formula P internal and not the P external. Because all the measurements that we are doing, all the functions, all the variables that we are having, they are all of the internal of the system. We are not talking about the volume that is outside. We are not talking about the temperature that is outside the system. We're talking about the volume, temperature, and everything that is inside the system. So why not pressure should also be inside the system? That is why we will write this above formula that we just derived in terms of P internal. So please write the next heading. All of you understood why do we need this? Yes or no? Please tell me in terms
Yes,
of
sir.
Yes,
P internal. Okay, in terms of P internal. Now, as you know, we are applying very small force. We're applying very small pressure also, right? Now, when, if you remember what we are doing, please remember what we are doing. If nothing is happening in the system, then at that time, I will say at equilibrium. When nothing is happening at equilibrium, जो आपका अगला chapter है, what happens at equilibrium? P external, it is equal to P internal. No changes happening. That is why piston is its own place. Now let us suppose I drop a grain of sand here. I dropped a grain of sand here. Now, obviously, what will happen? This grain of sand will exert some kind of pressure. Correct, guys? Yes or no? Please tell me. It will exert some kind of pressure, and the piston will move DL direction. All of this is correct. Yes or no? All of you, please tell me.
Yes, sir.
Yes, sir.
I am just putting a grain of sand or grain of whatever you can imagine, wheat or rice or something like that, and it will now. Please remember. Now the external pressure is greater than the P internal. So P external is greater than P internal. And what is the amount by which it is greater? Like कितना ज़्यादा है? तो पहले कितना था? P external, initially it was P internal, and as soon as I added a grain of salt, it became dP. So the increase in pressure, it is equal to how much? dP. And we have seen that dW, it is equal to minus of P external into dV. Now I can write dW, it is equal to integration of, not integration, let me just put up the formula first of all. Minus P external is equal to P internal plus dP, P internal plus dP into dV. Now I will integrate on both the sides, integration and integration. So dW will be becoming what? Work reversible will be equal to the integration of, minus bar le lete, integration of the P internal multiplied by dV, P internal multiplied by dV, minus integration of dP into dV. Correct है guys? Yes or no? Please tell me. इतना सबको समझ में आया? हाँ या नहीं, ये बताइए.
Yes, sir.
Yes, sir.
All of you understood till here ना? Yes or no?
Yes, sir.
एक बार देख लीजिए, बिल्कुल देख लीजिए, पर ध्यान से. Okay, now moving. See, dP is a small change in what? dP is a small change in pressure. dV is a small change in what volume? Small change in volume. Now imagine multiplying two numbers like this: 0.001 into 0.0001. This will be equal to how much? Tell me, guys. 0. How many zeros? Actually, ऐसे बता दीजिए आप लोग. Maybe you are not very comfortable like this. I can write this as 10 to the power minus 3 multiplied by 10 to the power minus 4. This will be equal to 10 to the power minus how many? What number? 10 to the power minus 7. I hope all of you understand. See here, guys. When we multiply two very small numbers, the result is even smaller. That is why we will be ignoring dP into dV, because both of small change into small volume, almost negligible. Is this understood? Yes or no? Please tell me. All of you understood why we are neglecting it? Okay, very good. That means the W reversible that we are talking about will be only equal to minus the integration of P internal into dV. Now, there is one formula that you have not learned, which is PV is equal to nRT. Have you seen this before? Anyone?
No, sir.
No, you have not seen this before. See, बहुत आसानी से समझ सकते हैं आप इसको. ठीक है? देख लीजिए all of you guys. If I increase the temperature, what I am doing, I am increasing the temperature, and the system is a closed system. Okay, so the particles will apply more pressure in the walls of the container. Correct, guys? Yes or no? Please tell me.
Yes, sir.
So I can say that pressure, it is directly proportional to temperature. Correct? है ना? बताइए.
Yes, sir.
If we are increasing the temperature, the pressure will increase. Or another thing that can happen is what? If the piston is movable, then I increase the temperature. Then what will happen? The piston will move and the volume will increase. So I can say volume, it is also directly proportional to temperature. Correct, guys?
Yes, sir. Yes.
Okay. Now, both of these things, pressure and volume, they will increase. I mean, depending on rigid boundary or flexible boundary. If we have rigid boundary and I add more and more moles of gases, first I had 1 mole of gas, then I had 3 moles of gas, then I had 100 moles of gas. If I keep on increasing the number of moles of gases, the pressure inside the system will also increase. Just imagine when you blow up a balloon, then what happens? Why does the pressure also increases, right? Yes or no? Please tell me. And you can also see if you add more number of moles of gases, then the volume also increases if it is flexible. दोनों बात समझ में आई हाँ या ना? बोलो भाई. All of you understood this?
Yes, sir.
So we can say pressure, it is directly proportional to number of moles, and volume is also directly proportional to number of moles. Now if we add this up, then we can say pressure and volume both are directly proportional to number of moles and temperature. Correct? देखिए PV
Yes,
तरफ आ
sir.
रहा है. And then I can say PV, it is equal to N, some constant R multiplied by T. Now you understood this formula, yes or no? Please tell me. R is just some constant. We will understand what is that constant. It's a constant. Got it? PV is equal to nRT. All of you.
Yes, sir.
Okay. Now I can write pressure, it is equal to nRT by V. Is that right? Pressure inside the system, whatever pressure is inside the system, it will be equal to nRT upon V. Na? Pressure, it is equal to nRT upon V. Yes or no? अरे दिख रहा नहीं दिख रहा सबको हाँ यार आप कुछ तो बोले हैं.
Yes.
Okay, fine. Now I can write this as minus integration of P internal is equal to nRT upon the volume into dV. This is work reversible. Now what I can write here is, please see, nRT upon V will be taken outside. Only nRT is taken outside. And then we have the integration of dV upon V. So anyone knows what is the integration of 1x dx or dx upon x? Does anyone know this? या नहीं पता किसी को? Nobody. चलिए ठीक है. I will tell you 1 upon v, it is equal to ln v. This will be equal to what? Ln x. Okay. देख लीजिएगा, you can see in the integration chart if you have it. Now, integration of dv upon v will be equal to, in square brackets, ln v. What is ln? It is log. Okay, log with the natural base that we call natural log. ln v from where to where? v1 to v2, है ना? अच्छा, हम लोगों ने v1 से v2 नहीं लिखा था, v1 से v2 लिख देते हैं. v1 to v2 is just v initial to v final, nothing different. And now minus nRT, we will have ln v2 minus ln v1. Now property of log is log of a by b, it is equal to, my bad, I should write it log this, log of a minus log of b is equal to log of a by b. So I can write this as minus nRT ln v2 upon v1, and log is in the base of e, that is a constant that we are not very familiar of. That is why if I have log with base e, so this is ln x. ln x क्या होता है? Log x with base e. If I want to convert this to log with base 10, so log with base e of x is equal to log of, rather I should write it like this, 2.303 log of 10 log of x to the base 10. So replacing ln v2 by v1 as minus nRT into 2.303. Now we have log of v2 upon v1. Now you can write this as, इसको आप लोग बहुत अच्छे से लिख दीजिएगा, rv it is equal to minus 2.303 nRT log v2 upon v1. This is very important. ठीक है? अब भले ही आपको बहुत सारी चीजें इसमें नहीं समझ में आ रही हैं, because again, first of all, you had the PV is equal to nRT वाला लोचा. Then we had the integration. Many of you did not know what is the integration of 1 upon x dx. Then many of you don't know what is log a by b and log a minus log b वाला. ठीक है? So उन सब चीजों को थोड़ा सा साइड में रखते हुए, remember, try to remember this form. है ना? Some things it comes slowly. तो धीरे धीरे आपको आ जाएगा. जैसे जैसे we will be discussing log also, but not right now, because we have to discuss log at a bit of stretch. Okay, so just keep this formula right now, and then when we will understand log, तब आपको ये और समझ में आ जाएगा. And for this, I would just suggest to look at any of the integration chart if you have. I hope आपने कुछ तो बना के रखा होगा, at least for physics तो काफी इस्तेमाल होता है. ठीक है? So look at that chart, you will understand this. Understand की बात करें तो आपको याद करने की चीज है कि 1 upon x का इंटीग्रेशन ln x होता है. अच्छा, एक हम बता रहे हैं, सबको डिफरेंशिएशन आता है. ऑल ऑफ यू नो व्हाट इज डिफरेंशिएशन? ये सुनो, अब्दुल हमीद, मार्टिन,
Yes, sir.
मरियम, ऑल ऑफ यू नो. ठीक है. फॉर एग्जांपल, इफ यू हैव dx स्क्वायर अपॉन dx, क्या होगा इसका? बताइए जरा. x स्क्वायर का क्या हो जाएगा डिफरेंशिएशन?
2x.
2x. ठीक है. मान लीजिए if you have d pi to the power 4 upon d pi, फिर इसका क्या हो जाएगा? How much this will be if you have power 4?
4 by 3.
4 by 3.
4 pi cube. Pi is a constant. Pi is a constant. It will be equal to how much? 0. फंस गए आप लोग. 0 होगा ना. Differentiation of a constant is how much? 1 or 0? क्या होता है?
0.
तो pi to the power 4 क्या है? Constant ही तो है.
Yes, sir.
Yes, sir.
जाके फेमस कर दीजिए ना अपने स्कूल में आपको. चलिए, छापे आप लोग ने, हाँ या ना? Done everyone? Right, try to
Sir,
remember
sir.
this. You're writing?
Yes, sir.
Acha, please write. Let me know once you're done.
Sir,
Yes, Mariam, tell me.
do we have to learn this derivation, like practice it?
No.
Okay.
No.
Done, sir.
Done, no? Okay. Now, let us try to understand the PV is equal to nRT thing. And let us understand the relationship. We have seen the relation of pressure and volume, both of these things related to number of moles and temperature. Now let us see what is the relationship between pressure and volume. What is the relationship between pressure and volume? So I think this is the easiest thing to understand. If I increase the pressure, if I mean put some external pressure, so obviously inside the system, what will happen? The pressure will increase. Yes or no? Please tell me. Correct. I'm increasing the pressure.
Yes, sir.
Yes,
So
sir.
the what is happening to the volume? Tell me, guys. If the piston is going down, volume is
Decreasing.
decreasing. So pressure is increasing, so volume will decrease. That means I can say pressure and volume, these are what inversely related. Correct? बोल सकते हैं हम?
Yes, sir.
Okay. अच्छा. अब ये देखिए आप ऐसा कुछ लिख सकते हैं. Pressure is equal to some constant divided by volume. हाँ या ना? लिख सकते हैं?
Yes.
Okay. So P into V is a constant. For a system, pressure into its volume is a constant. That means, let us suppose the initially we had P1 and V1, and finally we had P2 and V2. Then in that case, P1 V1 will be equal to P2 V2. सही है? आया ना? बताएं. ये समझ में आया? Initially the pressure was P1, the volume was V. Finally the pressure was P2, the volume was V2. So P1 V1 is equal to P2 V2 because P into V, it is a constant. All of you got this? Please tell me, guys.
Yes, sir.
Okay, now please see here. P1 upon P2 will be equal to V2 upon V1 by rearranging. Try to focus here. Is this clear?
Yes, sir.
Okay, so I can, instead of V2 and V1, I can also write it what? I can also write it as P1 by P2. Got it?
Yes, sir.
Please write this time. Now, work reversible, it is equal to minus 2.303 nRT log P1 by P2. Let me know once you are done writing. सबने लिख लिया, हाँ या ना बताएं। ऑल ऑफ इट डन ना? चलिए, एक चीज जो बहुत ही इंपॉर्टेंट है इज राइट हियर, आइसोथर्मल एक्सपेंशन। अच्छी तरीके से इसको समझने की कोशिश करेंगे, ठीक है ना? उसके बाद वी आर गोइंग टू राइट द कंक्लूजन। व्हाट इट इज सेइंग, आइसोथर्मल, टेल मी गाइस, आइसोथर्मल, अरे बोलो यार, नहीं बोलोगे नहीं सुन। आइसोथर्मल एक्सपेंशन, दैट मींस व्हाट इज हैपनिंग, एक्सपेंशन का मतलब क्या होता है? वॉल्यूम का इंक्रीज होना या डिक्रीज होना? एक्सपेंशन मींस वॉल्यूम इंक्रीजेस और डिक्रीजेस?
Increase.
Increases. And isothermal means temperature changes or is it is constant? Please all of you guys please say these things, otherwise नहीं समझ में आएंगी चीजें, ठीक है ना? बहुत हम आपको इतनी देर से बोल रहे हैं। अब्दुल हमीद, मार्टिन, सिद्दीका, we are also not answering anything. Abdullah, isothermal means temperature will be constant or it will be changing?
Constant.
Constant.
Constant. Very good. Isothermal means constant. That means आइसोथर्मल एक्सपेंशन का मतलब क्या हुआ, पहले वो समझिए। दैट इंक्रीज इन वॉल्यूम, इंक्रीज इन वॉल्यूम एंड टेम्परेचर इज कांस्टेंट। अब ध्यान से एक बात सुनिएगा, प्लीज डोंट राइट एनीथिंग, प्लीज डोंट राइट एनीथिंग। Let us suppose you have some kind of container like this. You have some kind of container. Please don't try to write anything. Now, here inside we have some gas. Inside we have some gas particles. If we are going to heat it, then a few things can happen. First of all, if it is fixed, that means there will be no change in volume. Delta V will be equal to, अच्छा ये केस बिल्कुल अच्छे से लिख के बता दे रहे हैं आपको, लिखने की भी कोई जरूरत नहीं है। If first case, if you have rigid boundary, then delta V will be equal to 0 and all the energy that is given to the system, please try to understand, we are giving energy to the system and we are observing the change. So when we give energy to the system and the boundary is rigid, then in that case there will be no change in volume and all the energy that you are giving will be used to increase the temperature. Is this clear? Yes or no? Please tell me.
Yes, sir.
ठीक है. Second
Yeah.
point, please write, if you have flexible, in flexible boundary, what will happen if you are having flexible boundary and there is some volume change, volume is positive, delta V is positive, that means volume बढ़ रहा है, ठीक है, volume बढ़ रहा है, and let us suppose whatever energy we are giving, what I am saying, whatever energy I am giving, it is used to increase the volume, it is used to increase what, it is used to increase, अरे बोलो भाई,
Volume.
it is used to increase volume, then in that case temperature में कोई चेंज आएगा? बताइए. अगर whatever energy you are giving, it is consumed in what? It is consumed in increasing the volume, so T is constant. ये बात क्लियर हुई कि नहीं, ये बताएं आपको सबसे पहले.
Yes, sir.
अब ये देखिए, डेल्टा V is positive, तो expansion T is constant, तो it is isothermal expansion. यहाँ पे डेल्टा V तो 0 है, तो एक्सपेंशन तो हो नहीं रहा, बट डेल्टा V 0, that means volume is not changing. So this is iso. क्या बोलते हैं जब वॉल्यूम सेम रहता है, बताइए जरा, बोल के सब क्या बोलते हैं when volume is same? Iso.
Choric.
Isochoric process. This is isochoric. अब थोड़ा ध्यान से सुनिएगा, थोड़ा ध्यान से सुनिएगा. Temperature it is constant here, volume is increasing. Temperature is constant, and what is happening? The volume is increasing. Next case will be, in some cases, delta V it is also positive, and temperature it is also increasing. Temperature is also increasing. Fine. अच्छा, some cases में ये भी हो सकता है आपके पास कि delta V it is equal to positive, and the gas expands so fastly that temperature decreases. ठीक है, this can also happen, but that are the later cases. अभी हम लोग इस पे फोकस करेंगे in this case. ठीक है, now please see. When we have a isothermal expansion, then what is going to happen? Delta V it is equal to positive and T is constant. And T is what? T is a constant. यानी कि एक चीज हम ये जरूर कह सकते हैं that whatever energy we are giving to the system, that energy is totally consumed in doing the work of lifting the piston up. Correct? है ना?
Yes, sir.
That means the change in isothermal expansion internal energy does not change. Internal energy is constant because whatever is constant, because whatever energy you are giving, the system is doing the work and it is spending that energy, Therefore, delta U it is equal to what? Q plus W. And delta U is what? Internal energy is constant. That means change in internal energy is 0, will be equal to Q plus W. And then we can write Q it is equal to minus of W. ठीक है, so this is an important result जो आपको याद रहना चाहिए कि isothermal expansion में internal energy 0 होती है, उसी वजह से we can derive the heat exchange by looking at the work done. चलिए इसको छापिए. अब हम आपको बताते हैं कि what is the use of this particular formula, है ना, and how beautiful it is. एक how ना beautiful का मतलब होता है कि how useful it is. ठीक है, कितना यूजफुल है वो हम आपको दिखाते हैं. पहले लिख लीजिए इसको आराम से बिल्कुल. In isothermal expansion, internal energy is constant. Therefore, delta U it is equal to Q plus W, and since delta U it is equal to 0, Q plus W will be equal to Q plus W, and Q is equal to minus W. जल्दी इसको लिखिए, फिर हम आपको बताते हैं. There is one thing in science which is not very much appreciated at your high school level, है ना, जो सीनियर सेकेंडरी स्कूल होता है या फिर स्कूल्स होते हैं उस लेवल में साइंस की एक चीज जो मतलब जिसको उतना अप्रिशिएट नहीं किया जाता, दैट इज द मेजरमेंट पार्ट. ठीक है ना, कि क्या मेजर करना आसान है, फॉर्मूला उसी की बेसिस पर रहता है. ठीक है, सो व्हेनेवर you see a new formula, as you saw that when we were doing in the terms of P external, the formula was very small, but as soon as we switched to P internal, the formula became very long. तो साइंस चीजों को हार्ड करने तो आया नहीं. दिस शुड बी अ लॉजिकल, आई मीन आपको बातें करनी चाहिए इस तरह से. साइंस चीजों को हार्ड करने तो आया नहीं. इट इज नॉट देयर टू मेक थिंग्स हार्डर, राइट, इट इज देयर टू मेक थिंग्स इजियर. सो ये छोटे फॉर्मूले से बड़े फॉर्मूले तक जाने का क्या पढ़ना है, लाइक व्हाई वी आर गोइंग फ्रॉम अ स्मॉल फॉर्मूला टू अ लार्जर फॉर्मूला. तो पढ़ना इसलिए किताब में दिया हुआ बस इसलिए नहीं. सोचिए उस बारे में. But why it is there? It is there because measurement of P external is very difficult. आप imagine करो, how will you, if you are measuring the P external, that means you are measuring what? You are measuring the pressure of the surrounding. What is surrounding? Everything in the universe apart from the system is surrounding. How will you measure? It is impossible. That is why what we can measure is P internal. We can accurately measure what P internal. That is why we have to switch the formula in terms of P internal. अब देखिए, right now it must be difficult for you guys to learn this long formula in terms of P internal, but imagine that formula is the thing, right? You can just plug it in inside any computer. You can just give it the values, input, volume and volume 2. इतना imagine कर लीजिए ना, अगर आपको कैलकुलेटर दे दिया जाए तब तो वो फॉर्मूला बहुत आसान हो जाएगा, right? That is why we are using P internal. क्योंकि P external तो नहीं कर सकते, यूनिवर्स पूरे सराउंडिंग का कैसे मेजर करेंगे? आप ध्यान दीजिए इस बात को, प्लीज ध्यान दीजिए. Why we are writing Q it is equal to minus W and we have not written it the other way around. I can also write this now that W it is equal to minus Q. ऐसे भी तो लिखा जा सकता था. हाँ या ना? All of you guys please tell me.
Yes.
Yes.
Sir.
But why are we writing that Q? That means we are what we want. We want what is heat. We want what is heat used in the process. और ऐसा लग रहा है कि W दिया हुआ होगा, उसमें बस नेगेटिव मल्टीप्लाई करना है. Yes, that is accurately what is happening. Please imagine yourself that this is just a gas stove. This is just a gas stove. Okay, this is just a gas stove and it is heating a system. Can you measure? अब सोचिए जरा ना, can you measure what is the energy given by this particular burner? मेजर कर सकते हैं? सोचिए जरा कैसे मेजर कीजिए. अगर मेजर कर सकते तो सोचिए जरा, what instrument will you use? 30 seconds सोचिए. I will give you some time. Can you measure the heat given by the burner? कितना heat दे रहा है? In terms of joules. In terms of joule, what is the transfer of energy हो रहा है? Heat से, heat के through. So what is the heat given by the? What is the heat given by the burner to this container? किसी के ख्याल में कुछ भी आया? हर्षा, सिद्दीका, सारा, मरियम, मार्टिन, अब्दुल हमीद, कुछ आया दिमाग में कि we can measure it using this device? Harsha, anything? Harsha?
Yes, sir.
Anything that comes to your mind? How will you measure the heat given by the burner? कितना heat मिल रहा है burner से? सारा, anything? कुछ आ रहा है दिमाग में? नहीं आ रहा है, बताइए. यस सर, am I audible? ऐसे शांत हो गए थे, क्या पूछ लिया हमने? अरे हाँ ना पूछना चाह रहे हैं, हम ऐसे आपको एकदम बिल्कुल जोर लगा के नहीं बोल रहे हैं कि आ ही जाना चाहिए जवाब. आपने सोचा 30 सेकंड तक, कुछ आया दिमाग में? बस वो पूछ रहे हैं.
No, sir.
नहीं कुछ आया. मरियम? मरियम?
No, sir. No, sir.
सिद्दीका, एनीथिंग? अब्दुल हमीद, एनीथिंग?
The thermometer.
थर्मोमीटर. थर्मोमीटर से टेम्परेचर मेजर होगा, हीट कहाँ से मेजर होगा? थर्मोमीटर आप सोचिए जरा. हाँ सारा, ठीक है, चलिए थर्मोमीटर आपने कह दिया, ठीक है, लेकिन तो उससे तो टेम्परेचर मेजर होता है ना, उससे हीट थोड़ी ना मेजर होती है. समझ में आ रही है आपको? ठीक है. और दूसरी चीज, आई होप आप थर्मोमीटर वहां ऐसे लगाइएगा नहीं, ठीक है? सीधा हीट के मतलब सोर्स ऑफ हीट में नहीं लगाया जाता थर्मोमीटर. इट इज जस्ट यूज्ड टू मेजर द टेम्परेचर, नॉट द हीट. अब वो इस वजह से यू डिड नॉट गेट एनीथिंग इन योर माइंड, बिकॉज ऐसी कोई चीज ही नहीं है फ्रॉम विच वी कैन मेजर द हीट. So if we cannot measure something, what do we do? दो ही चीजें हैं. ये चीज बताइए कितना बोलते हैं आप लोगों को? दो ही चीज. There are only two ways of getting a value in science. If you want a number, तो दो रास्ते हैं आपके पास. Either you can use a device to measure whatever property, whatever value you are having. This is a temperature. If you want to measure the temperature, you want a number for temperature, कि temperature क्या है, कितना है, then you will use a device. What is that device? To measure temperature, what is that device? Tell me guys, जल्दी बताओ यार.
Thermometer.
Thermometer. Another thing is that you can calculate. अब कैलकुलेट करने में क्या होता है ना, ध्यान दीजिए, बहुत पता नहीं आप लोगों को बताया कि नहीं बताया. Have I given this example of volume of a cube and side of a cube? बताइए. ये वाला एग्जांपल दिया आप लोग कि नहीं दिया हुआ? नहीं दिया हमने अभी तक. ठीक है, ध्यान से ध्यान से सुनिए. This is science. This is actually science. बाकी सब चीजें तो आउटकम है, बस यही है. या तो मेजर करोगे आप, या तो कैलकुलेट करोगे. सारे फॉर्मूले यहीं से आते हैं. आप जिस चीज को, if you cannot measure something, then you have to calculate. For example, think of a device that can measure the volume of a cube. Think of a device that can measure the volume of a cube. ऐसे आपने डिवाइस लगाया और आपको वॉल्यूम पता चलता है. थोड़ा सा सोचना ही काफी होगा आपके लिए, बहुत ज्यादा डिफिकल्ट नहीं है ना? हाँ ना में आंसर आ जाएगा. थोड़ा सा सोच के अगर आंसर नहीं आ रहा तो डिवाइस नहीं समझ लीजिए, ठीक है ना? हर्षा, एनीथिंग?
No, sir.
नहीं आ रहा दिमाग, ठीक है. अच्छा, वॉल्यूम का फॉर्मूला क्या होता है? वॉल्यूम ऑफ अ क्यूब इट इज इक्वल टू, बोलो भाई.
L cube.
हाँ, एल क्यूब.
Okay.
अच्छा, अब लेंथ मेजर करने के लिए कोई डिवाइस बताइए. लेंथ तो चाहिए अब ना. कैन वी मेजर लेंथ? लेंथ मेजर करने के लिए कोई डिवाइस होता है? दिमाग में आ रहा है?
Okay.
स्केल. बात समझ में आ रही है? कैन यू सी थिंग्स हैपनिंग कि कहां अब आपको लेंथ मेजर. अब देखिए, जो लोग ना, जो सवाल आपको 10th क्लास में दिया जाता था, इफ द वॉल्यूम ऑफ अ क्यूब इज दिस मच, फाइंड द लेंथ. बेकार सवाल, बकवास सवाल, अनयूजफुल. अगर आप इमेजिन करो रियल लाइफ में वॉल्यूम दिया जाए, बोला जाए कि लेंथ क्या है इसका, आपको अगर एरिया बता भी दे वो, एंड इफ दैट अगर वो आपको वॉल्यूम बता भी दे, एंड इफ दैट वॉल्यूम इज नॉट अ परफेक्ट क्यूब, if it is not a perfect cube, you will not be able to find the length. And even if, but उससे आसान तो ये है ना कि आप क्या करो, स्केल ले जाके मेजर कर लो. समझ में आ रही है? if you have been given a cube, आपके है रियल लाइफ में क्यूब है, उसका पूछा जा रहा है लेंथ क्या है, then you will not go to the calculator. हाँ, वॉल्यूम बता भाई, हम फिर लेंथ बताते हैं. आप बोलोगे स्केल दे तो बता रहे हैं. Is that right? Yes or no? Please tell me.
Yes,
ये बात
sir.
समझ में आ रही नहीं आ रही? ठीक है ना? तो सारा का सारा सार यहीं पे है that there are only two ways. Either you will use a device to measure something or you will use a formula to calculate something. जहां जहां फॉर्मूला आ रहा है ना, आप देखो वहां पे, आप वहां पे देखो ना, लेंथ कितना आसान है मेजर करना, कितना आसान है. Like it is exponentially easier than measuring volume. Whatever device you will be using to measure volume, I don't know, but length is easier to measure. That is why we have a formula. V is equal to L cube. That means measuring the length is easier. That is why we have now formula Q is equal to minus W, which means measuring of W is easier. अरे ये बात समझ में आई कि नहीं आई? सही है.
Yes, sir.
Yes, sir.
आप समझते हैं जरा अपना केस, ये तो पुरानी बात है, ठीक है ना? देखिए, समझिए, आपको कुछ नहीं करना है. आपको अपने गैस लिया, कुछ अपने गैस वैस ले लिया, कुछ भी, है ना? आप हीट कर रहे थे सिस्टम को, यू आर हीटिंग द सिस्टम, and you have to make the boundary flexible. You have to make the boundary flexible. And initially it was at this position, और फिर वो इस पोजीशन में आ जाएगा. ठीक है? So this is the change in the length. अब ये आपको लेंथ जो भी चेंज हो रहा है यहाँ पे, whatever length is changing here, that you can measure using a ruler as it is. Very easy. Another thing that you know, that this piston is in its place here because there is a constant pressure of 1 atm from the atmosphere. 1 atm का प्रेशर लग रहा है हमेशा इस पे. ठीक है? अच्छा, मान लेते हैं that the work is, मान लीजिए the work is what it is, irreversible. तो आप W निकाल सकते हैं कैसे? minus P external multiplied by what? Multiplied by delta V. तो डेल्टा V कहां से निकलेगा? ये जो पिस्टन है इसका एरिया आपको पता चल सकता है ना, रेडियस माप लीजिए, एरिया निकल जाएगा. सो यू कैन गेट दिस फ्रॉम A into L एंड P एक्सटर्नल आप ले लीजिएगा 1 atm. तो W निकल जाएगा आपको, हाँ या ना बताइए? यू गॉट द W?
Yes, sir.
Yes or no? You will get the W as some negative thing because work is done by the system. और मान लीजिए ये आपका निकल गया 50 minus 50 joules. Q कितना हो जाएगा? प्लस 50 joules. बस आपको ये चेक करते रहना है कि यहाँ पे जो टेम्परेचर है वो चेंज ना, टेम्परेचर कैसा रहना चाहिए, बस कांस्टेंट. तो सी वी आर यूजिंग डिवाइसेस. आप सोचो ना क्या क्या, अब जब हम टेम्परेचर बोलते हैं ना, दिमाग में आपको बत्ती जलना चाहिए कि थर्मोमीटर, मतलब ऐसे सवाल तो ऐसे दे देता ना खोल के, टेम्परेचर इज नॉट चेंजिंग. कैसे पता टेम्परेचर इज नॉट चेंजिंग? थर्मोमीटर लगाया हुआ तब तो थर्मोमीटर, टेम्परेचर इज नॉट, थर्मोमीटर लगाया है. देन वी आर मेजरिंग द लेंथ, हाउ? स्केल यूज होगा. Then we are measuring what? Then we are measuring the area. How? Radius we can measure of a cylindrical lid, and the pi r square will be the area. Pi r square will be the area. Area निकलने के लिए आपको स्केल चाहिए. कितनी छोटी छोटी चीजें हैं, कितनी छोटी। थर्मोमीटर सब घर में मौजूद, ऑल ऑफ द ईच एंड एवरी होम हैज थर्मोमीटर, ईच एंड एवरी होम, ईच एंड एवरी स्टूडेंट हैज अ स्केल, ईच एंड एवरी स्टूडेंट हैज अ स्केल। 1 क्लास के बच्चे की बात होता है। आप सोचो जरा, जिस हीट को जिस हीट को मेजर करने के लिए, मतलब आप दिमाग में ये नहीं ला पा रहे थे कि डिवाइस कौन सा यूज होगा, फॉर्मूले से वो चीज कितनी आसान हो गई। अब्दुल हमीद, मार्टिन, मरियम, सारा एंड सदीका, हर्षा, बात समझ में आ रही नहीं आ रही है बताइए?
Yes.
Yes, sir.
Yes, sir.
Yes, sir.
ठीक है, सो दिस इज द ब्यूटी ऑफ साइंस, कि कुछ चीजें जो आप सोच भी नहीं सकते, उन चीजों का मेजरमेंट कितना आसान हो जाता है बाय यूजिंग फार्मूला। तो फार्मूलोस को मत कोसिएगा, बड़े हो जाए फार्मूला चाहे जो भी हो, लेकिन आप ये समझिएगा ये फार्मूला बड़ा इस वजह से है बिकॉज अगर ये फॉर्मूला नहीं होता तो ऐसा डिवाइस हम सोच भी नहीं सकते जो ये वैल्यू लेके आ रहा है। जैसे फॉर एग्जांपल यहाँ पे, अच्छा उसी तरह देखिए, अगर रिवर्सिबल होता मामला पूरा, तो वी वुड बी यूजिंग दिस फॉर्मूला ऑफ पी एन करनी है ना, V2 अपॉन V1 वाला फॉर्मूला हम लोग देख लेते, वॉल्यूम पहले कितना था और वॉल्यूम बाद में कितना है। ठीक, नाउ ऑफ इफ यू हैव अंडरस्टूड दीज थिंग्स, तो हम फिर आगे बढ़े, थोड़ा सा एक सवाल कर लें, बताइए हाँ या ना।
Yes.
देखिए
So can
एक
I
तो
write
चीज हो
this?
गई कि अच्छा लिखा ही नहीं है क्या? कुछ नहीं लिखा है, कुछ नहीं लिखा तो लिख लीजिए, लिखना तो है। ये मत लिखिएगा ये सब, ठीक है ना, ये सब मत लिखिएगा। ये सारी चीजें समझने की है, दिमाग में आपकी होनी चाहिए कि पढ़ कर क्या रहे हो क्या रहा है यहाँ पे, पता ही नहीं है। मतलब Q इज इक्वल टू माइनस फॉर्मूला क्यों है ये, उल्टा क्यों नहीं लिखा हुआ कहीं पे कि W इज इक्वल टू माइनस, बोलेंगे बेवकूफ है ना भाई तू, वर्क तो ऐसे ही मेजर किया जा सकता है, आसान है। हीट को मेजर करना डिफिकल्ट है, तो फॉर्मूला हीट के लिए चाहिए, डब्ल्यू के लिए नहीं चाहिए। ये दिमाग खुलता है जब आप साइंस मतलब करते हो, तो आप पढ़ रहे हो साइंस, व्हेन यू स्टार्ट डूइंग साइंस तब दिमाग खुलता है। जो टेम्परेचर इज कांस्टेंट ऐसे बोल के निकल जाता है सवाल ना, फिर जब एक्सपेरिमेंट करने जाते हैं तब अच्छा थर्मोमीटर लगे, सारी चीजें वहां से आती है व्हेन यू स्टार्ट डूइंग साइंस। एक प्रोसेस होता है डिस्टिलेशन, ऑल ऑफ यू हैव हर्ड अबाउट डिस्टिलेशन, यस और नो, प्लीज टेल मी।
Yes.
Yes.
है ना, आपने सेटअप देखा होगा, मतलब आई थिंक दैट इज वन ऑफ द मोस्ट ऐसा डायग्राम जो आई थिंक सब लोगों ने बनाया हुआ होगा, दैट यू हैव सम कॉनिकल फ्लास्क टाइप ऑफ थिंग हियर। कॉनिकल फ्लास्क तो ऐसे बर्न नहीं करना चाहिए, यू विल हैव राउंड बॉटम फ्लास्क फॉर द बर्निंग, इस तरह से राउंड बॉटम फ्लास्क होगा, एंड देन यू विल हैव हीट हियर, फिर ये ऐसे करके यहाँ से पाइप से जाएगा और यहाँ पे ऐसे इनलेट आउटलेट होगा, हॉट और कोल्ड का। याद आ रहा है नहीं याद आ रहा है?
Yes, sir.
Yes.
Yes,
Sir.
sir.
याद आ रहा है? अगर किसी का मतलब हुआ मामला डिस्टिलेशन करना पड़े कभी, तब आपका दिमाग है, तो डायग्राम तो बना लिया, इनलेट आउटलेट, या ये यहाँ पे ये पागल कर दिया, इनलेट ऑफ वाटर एंड आउटलेट ऑफ वाटर। इनलेट एंड आउटलेट इज मेसी, पाइप लगा, मतलब वैसे तो लिखा जाता है ना इनलेट आउटलेट, बस कहाँ से आएगा पानी, आएगा कहाँ से? नल होना चाहिए लैब में, लैब में नल होगा, ठीक है, आपने तो एक दे दिया इनलेट के लिए, पानी आ रहा है, अब पानी वापस जाएगा, और वापस जाएगा तो कहाँ जाएगा? सिंक में जाएगा, बर्बाद होगा पानी। फिर वो वापस थोड़ा सा लंबा घूम के वापस से इनलेट की पागल हो जाता है। लैब लैब में क्या कर रहे हैं आप लोग? टाइट्रेशन कर रहे हैं अभी? हैव यू डन एनी टाइट्रेशन गाइस?
Yes, sir.
What indicator you are using? Phenolphthalein.
Yes, sir.
चलिए, इज एवरीवन डन? आगे बढ़े हम लोग।
Yes.
चलिए, write a question. 2 liter of an ideal gas at a pressure of 10 atm expands isothermally. and isothermally at external pressure of 1 atm. How much heat is absorbed by the system and how much work is done by the system if gas expands to gas expands to 10 लीटर। ध्यान से सवाल को करेंगे बिल्कुल, ठीक है, ज्यादा गड़बड़ी नहीं करनी है। Once you will let me know once you're done writing the question. All of you done writing the question? Yes or no? Please tell me.
Yes, sir.
Yes,
Yes.
sir.
Yes. देखिए थर्मोडायनेमिक्स में ना बहुत बार ऐसा होता है that words are more important than numbers in numericals. Numericals में अक्सर आपने ये देखा होगा कि numbers का ज्यादा महत्व होता है ना, numbers are more important, but in thermodynamics the words will play a more important role in numerical. For example, here this word we have, it expands isothermally. As soon as you see expands isothermally, this line should strike in isothermal expansion. Internal energy is constant. That means delta U, it is equal to W, sorry, delta U, it is equal to 0, and Q, it is equal to minus W. These are the formula that we are going to use. Where did we come to know this from? ये सवाल आता ना सर, सवाल सर कौन सा फॉर्मूला लगेगा, आता नहीं आता बताइए। मरियम, सारा, सिद्दीक, और
Yes, sir.
तो कहां से पता चलेगा? वो सवाल बताएगा। फॉर्मूला कौन सा लगेगा, कौन बताएगा बताइए? हम फिर ना बताएंगे, कौन बताएगा? वो सवाल खुद बताएगा आपको कि फॉर्मूला कौन। यहाँ से समझ में आया कि नहीं? अरे हाँ यार, आप कुछ तो बोले। ठीक है, आप सुनिए ध्यान से जरा।
Yes, sir.
नाउ प्लीज, व्हाट इज हैपनिंग? सो वी अब हीट निकालना आपका काम नहीं है, हीट तो निकल जाएगा डब्ल्यू से, निकालना काम क्या है आपका? वी हैव टू कैलकुलेट दी डब्ल्यू। Now W, we know that W, it is equal to minus of P external into the delta V. ठीक है। अच्छा, आपसे पूछा जाएगा सर ये कैसे पता चलेगा कि एक्सटर्नल वाला लगाना है या इंटरनल वाला लगाना है? हम बोलेंगे भाई आसान कौन सा है? आप बोलोगे सर P एक्सटर्नल वाला तो आसान है फॉर्मूला। बोले अगर एक्सटर्नल दिया रहे तो एक्सटर्नल ही लगाना है। They are giving ना P external of 1 atm. If they have given you the external one, तो आप external ही लगाइएगा। And they have also given you the volume change, है ना? From 2 liter, it expanded to 10 liters. So P external is equal to minus 1 multiplied by delta V, it is equal to 10 minus 2. It will be pressure, it is in atm, volume will be in liters, so liter atm. So W will be equal to minus 8 liter atm. And this will be equal to how many joules? Tell me guys. 1 liter ATM, it is equal to how many joules? अरे ये बोलो भाई।
800.
100.
800 हो जाएगा ना? 8 into 100, that means 800 joules. So W, it is equal to minus 800 joules. 800 J लिख देते हैं बस, 800 G. And we know that Q, it is equal to minus of W. So this will be equal to minus of minus 800 joules. This will be equal to how much? Plus 800 joules, यानी कि 800 joules की एनर्जी आपने दी तो सिस्टम ने 800 joules का काम किया। और सिंस सिस्टम ने काम किया तो वर्क विल बी नेगेटिव, एंड सिंस सिस्टम को हीट मिली, सिस्टम गॉट द हीट, हीट विल बी इन पॉजिटिव। मेक सेंस? यस और नो? प्लीज टेल मी।
Yes, sir.
अरे बातें
Yes, sir.
हाँ ये समझिए जरा, उसको अच्छे से ना खुद को समझा समझा के चलिए, तो आप दौड़ा जाइएगा बिल्कुल। -800 +800 क्या ओ माय गॉड, समझिए इस चीज को क्या हो रहा है यहाँ पे। देखिए हियर यू आर गिविंग हीट कितना 800 joules of heat. Okay, then what is going to happen? All of this heat, it is going to get used to lift the piston up. That means to expand. तो कितना expand करने में कितना काम किया? Obviously the work done in expansion was 800 joules. And since the system is doing the work, we will put up the negative sign. हमारी यहाँ ना, all of you got this? Please tell me. अरे
Yes,
बोलो
sir.
भाई। ठीक है, अब देखिए अगला
Yes.
सवाल। Let us suppose all the conditions are same. इसको लिखना है क्या? No. ठीक है, चलिए। Right, next question. Same scenario. All of these things are same, है ना? All of these things are same. Just there is one difference. How much heat is absorbed? And how much work is done? If gas expands in vacuum या to vacuum. VAC UUM होता है, पता है आपको स्पेलिंग वैक्यूम का? कितने लोगों को पता था ये स्पेलिंग होती है वैक्यूम की? VAC WM या W तो होता है, डबल C होता है या नहीं पता आपको, याद है? VAC UUM, वैक्यूम का ये स्पेलिंग होता है, VAC UUM। आप लोगों को क्या लगता था? VACCUM?
No, sir.
बताइए, नहीं ना? ठीक है, अब बताइए, देखिए ये सवाल मिल गया आपको, कुछ नया नंबर आया यहाँ पे, बताइए तो जरा। इज देयर एनी न्यू नंबर?
No, sir.
नहीं, तो लग रहा है कि क्या हो, माय गॉड सर समथिंग इज मिसिंग। कुछ तो दे दो, केमिस्ट्री को से कुछ नहीं बताता है। ठीक है, तो यहाँ पे वही समझिए, हियर वर्ड्स प्ले अ मोर इंपॉर्टेंट रोल देन दी नंबर्स। अब ऊपर के केस में सिर्फ क्या चीज चेंज हुई है? एक्सपैंड्स इन, कहां एक्सपैंड कर रहा है बताइए जरा? इन वैक्यूम। एक्सपैंड्स इन, अरे बोलो भाई,
Vacuum.
वैक्यूम। अच्छा, नाउ टेल मी व्हाट इज द प्रेशर एट वैक्यूम? वैक्यूम में क्या प्रेशर होता है?
0.
वेरी गुड, नंबर मिला? हाँ, जनता को नंबर मिला कि नहीं मिला? सिद्दीका, सारा, मरियम,
Yes,
वर्ड
sir.
से नंबर मिला। अब बस कितना आसान हो गया ना, देखिए W, अच्छा अभी भी सारी चीजें सेम है, दैट मींस इट इज हैपनिंग, इट इज एक्सपैंडिंग आइसोथर्मली, बट एट एक्सटर्नल प्रेशर ऑफ 180 नहीं, इट इज एक्सपैंडिंग इन वैक्यूम राउंड। एक्सपैंड आइसोथर्मली तो हो रहा है, तो वी ऑलरेडी हैव दिस W, इट इज इक्वल टू, सॉरी, Q इट इज इक्वल टू माइनस W वाला केस तो हो गई। And now we need to calculate the W. W is equal to minus P external into delta V. अरे भाड़ में जाओ डेल्टा V, जाइए आप। Oh my God, 0 into delta V will be equal to 0. अरे दिखा कि नहीं दिखा, बोलो,
Yes, sir.
है ना?
Yes,
That is
sir.
why what we can say, Q it is equal to 0 and W it is equal to 0 when, कब? When we have expansion, rather I can say isothermal expansion, in vacuum, expansion vacuum, डेल्टा U तो 0 होगा ही होगा। Why? बिकॉज आइसोथर्मल एक्सपेंशन है, वैक्यूम में हो रहा है, तो Q भी 0 होगा, ना ही हीट एब्जॉर्ब हो रही है, ना ही वर्क डन होगा। प्रेशर कुछ है, मतलब कोई फोर्स रहेगा, उसके अगेंस्ट ही तो वर्क होगा, अपने आप वर्क नहीं ना होगा। ठीक है ना? इफ देयर इज नो, किसी चीज के अगेंस्ट वर्क, अगेंस्ट ग्रेविटी, इफ यू आर लिफ्टिंग समथिंग अप, बट अगर ग्रेविटी है ही नहीं तो क्या वर्क? अब देखिए ये रिजल्ट बहुत इंपॉर्टेंट है, सी दिस रिजल्ट, व्हेनेवर दे से in isothermal expansion in vacuum, work done will be equal to 0। और दूसरी चीज ध्यान रखिएगा, अगर सिर्फ ये कहे कोई, आइसोथर्मल ना कहे, एक्सपेंशन इन vacuum. So expanding, that means volume is changing, but since P external it is equal to 0, then in that case we can say that W will be at least equal to 0. Ab, whether there is some energy given or not, that is another case, because if the temperature is changing, so we will obviously say, yeah, there is some heat involved, but work done is equal to 0 if we have expansion in vacuum. Is that clear? Yes or no? Please say. ये बात समझ में आई सबको? हाँ या ना?
Yes.
ठीक है, इसी चीज को बोलते हैं फ्री एक्सपेंशन। ठीक है, तो आप यहाँ पे लिख लीजिए एक और पॉइंट, वर्क डन इन फ्री एक्सपेंशन इज इक्वल टू 0। अब आगे बढ़े जरा, हाँ या ना बताएं। Can I move on?
Yes.
ठीक, अब इसी केस में अगला सवाल है। ठीक है, एवरीथिंग इज सेम। ये जो सवाल कर रहा है इसके अलग अलग पार्ट्स उसको बहुत अच्छे से कर दीजिएगा। ठीक है ना, मतलब एक बार दो बार बिल्कुल एक एक पॉइंट समझ के लीजिएगा। मतलब ऑलमोस्ट स्टार्टिंग का जो आपको थर्मोडायनेमिक्स है, अभी हम लोग थर्मोडायनेमिक्स पढ़ रहे हैं, थर्मोकेमिस्ट्री नहीं पढ़ रहे हैं। ठीक है, वी आर लर्निंग अबाउट थर्मोडायनेमिक्स, जहाँ पे हीट और ये वर्क डन वगैरह हो रहा है, फिजिक्स जैसा लग रहा होगा बिल्कुल। अभी तक यहाँ पे कोई भी केमिकल आया ही नहीं है, तो दिस इज थर्मोडायनेमिक्स। थर्मोकेमिस्ट्री है जब केमिकल्स आएंगे। ठीक है, वो आसान है, काफी आसान। इसके बनस्बत अगर आप देखिएगा दैट इज वेरी इजी, एटलीस्ट जनरली बच्चों को थर्मोकेमिस्ट्री आसान लगती है थर्मोडायनेमिक्स से। ठीक है, तो यहाँ पे जरा देखिए, अगर हम केस बात करें, हाउ मच वर्क इज डन, हाउ मच वर्क is done if expansion takes place reversibly. Expansion takes place reversibly, है ना, वर्क निकल जाएगा तो फिर हीट भी निकल जाएगा। ठीक है, प्लीज सी हियर गाइस, still it is what, it is still isothermal expansion, but that expansion is taking place reversibly. That means our initial delta U it is equal to 0 and Q it is equal to minus W, it still holds, है ना। So we also have to calculate, वो heat भी calculate करना ही पड़ेगा ना, साथ में सवाल में को हमने लिखा नहीं, but this still holds and we can write W reversible। अब यहाँ पे इंटरनल प्रेशर का काम आ जाएगा because it is reversible in nature। W reversible will be equal to minus of 2.303 nRT log of V2 by V1, log of V2 by V1। अब ध्यान से सुनिए जरा, माइनस 2.303, इसको ध्यान से देखिएगा, nRT log V2 by V1। We know that PV it is equal to nRT, हाँ या ना, ये बताएं आप लोग। अरे बोलो
Yes,
भाई,
sir.
ठीक है, PV is equal to nRT। अच्छा, हम लोगों को पता है nRT क्या हो जाएगा, माइनस 2.303 nRT it will be equal to, देखिए ध्यान से सुनिएगा, यहाँ पे हम लोग क्या लिख देंगे, PV and log of V2 by V1। अब बच्चों को लगेगा सर देखिए दो प्रेशर दिया हुआ है यहाँ पे, सॉरी दो वॉल्यूम दिया हुआ है यहाँ पे, यहाँ 2 liter of an ideal gas at a pressure of 10 atm expands isothermally at external pressure of 1 atm, how much work is done। वो तो सारी ठीक है बात। और उसके बाद दिया हुआ है how much work is done by the system if the gas expands to 10 liter, if the gas expands to how much, बोलिए जनाब।
10 liters.
10 liters। ठीक है, अब यहाँ पे आपको बस ये चीज ध्यान रखनी है कि देखिए प्रेशर इज 10 atm, प्रेशर कितना है 10 atm, एंड इनिशियल वॉल्यूम इट इज इक्वल टू हाउ मच, इनिशियल वॉल्यूम इट इज इक्वल टू 2 liters। आपको लास्ट का लास्ट का आपको क्या बता दिया गया, वॉल्यूम तो बताया गया है, दे हैव टोल्ड व्हाट इज द वॉल्यूम एट द एंड, but they have not told what is the pressure at the end. So I will take the initial case, even though both the things are fine, because you know P1 V1 it is equal to P2 V2. They have given you the initial pressure, yes. Initial volume, yes. Final pressure diya hai? No. Final volume, yes. Now both of these things are equal. You can take initial case or the final case, but because they have not given us the final pressure, we will be using the P1 V1, that is 2 liters and 10 atm. ये बात समझ में आई सबको? हाँ या ना? पीवी में क्या लेना है बोलिए जरा.
Yes, sir.
Yes, sir.
Thank you very much. 303, and then we can do what? Into 10 into 2 liter ATM हो जाएगा यहाँ पे, है ना? 10 into 2 log of final volume was 10 and initial was 2. अच्छा ये 10, अच्छा ये एक सेकंड, ये आप लोग फिर बोलिएगा सर ये वॉल्यूम ही है क्या? हमने कहा नहीं. पीवी में अगर हम बात करें, सो प्रेशर इज 10 atm into volume is 2 liters and log of V2 is 10 liter divided by initial volume is 2 liters. So liter and 2 into 2 5s are 10. Now we will get this as minus 2.303 multiplied by 10 into 2 into log 5. Whatever this value will be, it will be in liter ATM. So instead of liter ATM, I will also multiply by 100. So minus 2.303 multiplied by 10 multiplied by 2 into log 5, it is equal to, anyone remembers the value? 0.7 hota hai. Multiplied by, instead of liter ATM, it will be 100 joules. 100 joules. अब जरा इसको कैलकुलेट कर लीजिए. So 7, so this will be 2 minus 2.303 multiplied by 7 to the 14 ना, 1400 हो जाएगा. देखिए तो जरा 1400 होगा ना. Here we have 1.4 into 3 zeros. Yeah, correct. 1400. अब इसको जरा मल्टीप्लाई कर लीजिए, कितना आ जाएगा? माइनस वर्क रिवर्सिबल. कितना जाएगा जरा बताइए जरा. नो आइडिया, नो आइडिया, किसी को नहीं आइडिया.
Minus 2,842.
कितना आता है? हमें तो सही नहीं लग रहा है. 3000 कुछ होना चाहिए मेरे ख्याल से तो.
Minus
2 4.2.
एक सेकंड में 2.303 मल्टीप्लाइड, सॉरी कट कहाँ से, into 1400. This is 3224.2. शायद हर्षा ये करे 3224.2 joules. ठीक है. Obviously Q कितना हो जाएगा? Heat will be equal to minus of minus 3224.2. So this will be equal to 3224.2 joules. ठीक है. अगर आप ये ध्यान रखें जरा, जो वर्क हम लोग के पास एयर रिवर्सिबल आया था, that was equal to how much? Minus 800 joules. So you can see that work reversible, it is quite higher than the work irreversible, है ना? And that is because जब slowly कोई चीज काम होता है ना, धीरे धीरे, like step by step, each and every whatever force you are, I mean if you are adding 1 grain of salt, 1 grain of sand, then उस एक grain का भी जो work होता है, that is counted. Then you add another grain, then you add another grain, then each and every grain's work is counted. But if you add instantly, there will be some work or there will be some pressure that is applied by the grains of sand which will be cancelled because of falling on each other. ठीक है. That is why एक और conclusion जो हम लोग यहाँ पे लिखने वाले हैं, that is maximum work is done in a reversible process. ठीक है. आप ये चीज और थोड़ा सोचिएगा इस बारे में कि और क्यों इस तरह से होता है. हम आपको थोड़े थोड़े से हिंट दे रहे हैं. ठीक है. फॉर एग्जाम्पल एक बात बताइए आप लोग, हाँ ना, भी लिखने हैं तो लिखना छोड़ दीजिए, तरह हाँ ना बताइए. इफ आई एम इंस्टेंटली pouring down all the sand, then there will be some sound, हाँ या ना? कुछ साउंड आएगा नहीं आएगा? आएगा.
Yeah.
So sound is also energy, right? कहाँ से आ रही है वो चीज? So obviously we wanted to do some particular work, that is shifting the piston down, है ना? वो काम था, that was our initial, that was our goal. But all the energy is not, I mean, it is not transferred in doing that particular action. कुछ sound energy में चला जाएगा. Some of the piston will be heated as a lot of rain falls on it. So some of it will be gone in heat energy. बात समझ में आ रही है सबको? हाँ या ना? ठीक है.
Yes, sir.
बट अब एक बात बताइए, हमने एक ग्रेन डाला, कोई साउंड आएगा? बताइए. तो आई होप नाउ यू कैन सी व्हाई ये चीज समझने वाली है कि व्हाई मैक्सिमम वर्क इज डन इन द रिवर्सिबल प्रोसेस. इरिवर्सिबल में ज्यादा काम क्यों नहीं होता है? ठीक है. सो दीज आर द रीजन कि जो वर्क है करना हम लोगों को वो नहीं होता. ऑब्वियसली एनर्जी कैन नॉट बी डिस्ट्रॉयड, कैन नॉट बी क्रिएटेड. सेम अमाउंट ऑफ एनर्जी इज गिवन इन बोथ द प्रोसेस, बट more useful work is there when we are doing things in a reversible manner. ये बातें अगर आपको समझ में आई हो तो आज we are going to conclude on a very beautiful thing. बिल्कुल आखिरी में we have seen delta U, it is equal to Q plus W. Then we saw delta U, it is equal to, we saw that we can calculate work using pressure volume work, Q plus minus of P external into delta V. And from this particular formula, we can have a plenty full of different scenarios. For example, isothermal. एक सेकंड, जरा हम ना इसको अच्छे से लिखना चाह रहे हैं, तो एक काम करते हैं.
Maximum work done
In reversible process. We have isothermal expansion. What happens in isothermal expansion? First of all, isothermal, that means T is constant. Another thing, that means delta T हम zero बोल सकते हैं. Temperature change is zero. Delta U, it is also equal to what? Zero. And the important thing, the most important thing, Q, it is equal to minus of W. Q, it is equal to minus of W. Then we can have another process. Isochoric process. ठीक है. In isochoric process, what will happen? Volume change will be equal to zero. That means work done will be equal to zero, and whatever internal energy change will be there will be only due to the heat involved in the process. ठीक है. अब आपके पास बाकी दो केसेस आ जाएंगे. One is free expansion. One is free expansion. We've also seen this. What happens in free expansion? The P external, it is equal to zero. Therefore, what will happen? The W will be equal to zero, and whatever change in internal energy will be only because of the heat exchange. ठीक है.
Yes, sir.
आप ध्यान से सुनिए जरा. एक चीज होती है जिसको हम लोग देखने जा रहे हैं, that is when you have isobaric. That means P external is constant. क्या constant होगा यहाँ पे? यहाँ से P external is equal to constant. We are having a constant pressure. Then in that case, whatever heat is involved, it is equal to a new term that we will study in the next class, delta H. That is enthalpy. Enthalpy का सीधा सीधा मतलब क्या है? It is the heat involved when we have constant external pressure. Are all of these things clear? Yes or no? Please tell me.
Yes, sir.
Yes, sir.
किसी को कोई दिक्कत तो नहीं तो बताइए. अब एक और चीज हम लोग एक चीज और देख लेते हैं. देखिए ये हम लोगों ने शायद देखा था इन एडियाबेटिक प्रोसेस. एडियाबेटिक